some things from fractions, okay? When we are adding or subtracting fractions, so this is kind of a review of adding, subtracting fractions, okay? So what if I have 3/4 plus 7/12? What is the thing I have to do before I can actually add those? What do you have to do? Yes?
Make the ones the same.
Yes, make the denominators the same. We have to get what's called common denominators. That's a fancy word for the same numbers on each bottom. Okay, so the bottom numbers are the same. That's what we have to do. So what we do is we can say, okay, what number does 4 and 12 divide evenly into it? So a common, making the numbers, bottom numbers, the same. And we ask the question, what does 4 and 12 divide into, both divide into or divide into, okay? So what number would you use as a common denominator here? 12, because both 4 and 12 divide into 12. So you can check it. 12 divided by 4 is 3. 12 divided by 12 is 1. So that means I would multiply this by 3 and 3. Okay, now we're not going to do that part, but that's how I get our common denominator. Okay, so this idea of getting our denominators the same is going to apply to when we solve equations that have fractions in them. Okay, so that's something what we want to look at. So that's what we're looking at. We need to get the bottom numbers the same, but we're actually going to find out that when we get the bottom numbers the same, in fact, I'll show you that right now. Let's do this one. So I'm going to multiply this one by 3 and 3, so that gives me 12 on the bottom. Okay, so I get 9 12s plus 7 12s. And when we add them, we get 16 12s. Excuse me. What we're going to find out is, see this statement? It's a true statement. 9 plus 7 is 16. So what we're going to do is we're going to actually, so if you multiply all of this by 12, everything by 12, it would get rid of those. And it would just have 9. So that's equivalent. 9 plus 7 equals 16 is actually equivalent to this in the fact that I can multiply each side. Remember, you multiply each side of the equation by the same number, and it actually will make it still equivalent. Okay, so let's go in and see how we're going to use this. Keeping the idea of common denominators or making both the numbers the same on the bottom. Okay. So we're going to see how we would use this. So basically, let's say we have a fraction like this. Okay. First thing you guys are going to do, oh no, it's got fractions in it. I must not be able to do this problem. That's what I usually hear, believe me. I've had so many people go, no, not fractions. Yeah, fractions aren't that bad. We just have to go back and remember how we work with them. Okay, so one of the things we can do here is we will look first for the common denominator. Okay, now if you don't understand that, it's look for what number do both of these go into. So we're looking at what number do both or do all denominators, can't spell, in a TORS go into. Okay, so if I look at this fraction, what is the common denominator for these numbers? Max?
15.
15, yes. Right now, if you look at this, so we could say, yes, 15 can be divided by 5 and 15 can be divided by 3. That's what we're actually saying, okay? Because, or 5 goes into 15 3 times, 3 goes into 15 5 times, okay? So what happens is we're going to, because it makes it true, as long as we do the same thing on both sides of the equation, the equations are equivalent. Remember, we've been doing this all along. We divide by a certain number, but we do it on both sides. We multiply by a certain number, but we do it on both sides. Okay? We're just going to use the distributive property, okay, on one side. So I'm going to multiply this by 15 and this by 15. If it makes it easier, put it 15 over 1. Okay? Because if you are, it's easier for you to understand when we're multiplying. The 15 is really 15 over 1, and you just multiply straight across, or we're going to reduce. Okay, so Matt, do you have a question?
Not mad.
I mean, Matt. Sorry.
Could I minus 1 over 3 on both sides? And then divide it by 3 over 5?
You
Like a
could,
normal-
but it's going to be harder.
Oh.
I'll just tell you, people make more mistakes. Because you still have to get a common denominator.
5.
Yes.
Yeah.
And then when you multiply it, you're going to get a different number, which just works. Yes, it works. Okay,
Yeah.
so the question was, can I just do it like normal with fractions? Absolutely. Okay, but if you don't like working with fractions, you don't have to do that. Okay, so I'm just showing you an alternative mode. We'll show you that it works both ways. Okay, so let's multiply these through. We're going to use distributive property. So 15 times 3, 15 over 1 times 3/5, whoops, x plus 15 over 1 times 1/3 equals 4 times 15. Okay, so what I want to check is I'm multiplying every term by 15. I multiplied this first term by 15, I multiplied the second term by 15, and I multiplied this third term on the other side by 15. So it's very important when you're doing this, you multiply every term by 15. Okay, now, the key that makes this work the best, 15 divided by 5, what does that give you? Because that's really what this is. What does that give you? 3. So we can change this to 3 times 3x. Because what's going to be on the bottom? A 1 and a 1. So we got rid of the denominator because now it's just a 1 on the denominator. So 3 times 3 is 9. I could put the 1 on the bottom, but that's really just the same as 9. Okay? So what we did is we got rid of that fraction. We got rid of the 5. Okay? Now I'm going to multiply this one, but again, we can cross cancel. 15 and 3. 3 goes in here once, 3 goes in here 5 times, so 5 times 1 is 5. Okay. Equals 4 times 15, which is 60. Now do you see that problem? It is a lot nicer because it's just like what we've been doing. We're going to solve it just like normal. So minus the 5 on both sides. So 9x is equal to 55. Divide by 9 on both sides. So x is equal to 55 divided by 9, which is reduced as far as it can be, because the only numbers that go into it are 11 and 5. The only things that go in here are 3 and 3, so they are not in common. I can't reduce. Okay, so we don't need to reduce this. This is the most reduced form of that. Okay. Yes, I can go back and put it into my original equation. I'll just tell you this is a lot more work, but it is very important to do. That's 55 over 9 plus 1/3 equals 4. So we can actually check it. Okay. Again, when you're doing multiplication, learn to cross reduce. It really helps. Okay. So you can take this, that's 1. So 3 goes into this once, 3 goes into this 3 times. 5 goes in here 11. So multiply, I get 11/3 plus 1/3 equals 4. Well, 11/3 plus 1/3 is 12/3. Is that a true statement? 12/3 or 12 divided by 3 is 4. Is that true? Is 12 divided by 3 equal to 4?
Yes.
Yes, it checks. Okay. Now this is reminding you, you have to go back and do memory check. When I'm multiplying, you can cross reduce. That means I know a 3 goes into this number and a 3 goes into this number. So I reduce it. 3 goes in there once, 3 goes in here 3 times. Then check, do these have anything? So we're looking, it's called cross reducing. Okay. 5 goes into this, 5 goes into this, so it goes in once, 11 times, and then I'm left with 1 times 11 and 1 times 3. Now look at, we already have common denominators, so I can add it very quickly, and it does equal 4. Okay? Always check your equations to make sure that they are correct. Okay. Now let's show it the way, so that's one way. I'm going to erase the check right now. I want to show you how Med did it so that you guys can see it can be done this way. So he subtracted 1/3 on both sides. Okay. So I'm just showing you how you can do it with using fractions. It is possible. I'll just tell you that most people like to do it where you clear the fractions. Okay. So we get 3/5 x equals, and I have to do 4 minus 1/3. So what would that give me? Do you guys know?
3 2/3.
It's actually 3 2/3. Okay. Because if I take 1/3 away, that's going to give me 2/3. And so I have 3 left. Okay. 3
Not the
whole
way I
numbers.
did it.
How did you do it?
I
Made a common denominator.
yeah.
And what did you get when you did that?
I got 12 over 3. I mean, I turned because
Yes, you got 12 over 3 minus
So
1.
then I got 11 over
Okay,
3.
let's see if we get that same thing. 3 times 3 is 9 plus 2 is 11 over 3. So yes, we do get it the same. Does that make sense? Review of fractions. You should all know fractions, but I know that's one of those that everybody goes, ah! Okay. So we want to get rid of this now. So I have 3/5 x equals 11/3. When I'm dealing with fractions, we multiply by the reciprocal. Okay, to get rid of this, to make it 1, we have to multiply by the reciprocal. So 5 divided by 3 is what we're going to multiply by. That gives me 15 over 15 x, which really is 1x. Okay, I'm just showing you it makes the 1x we're looking for. But we also have to do 5 over 3 here. Right? 5 times 11 is 55. 3 times 3 is 9. Look what we get. 1x is equal to 55 over 9. Do you see it's the same answer? You can choose which way you want to do it. But today we're gonna practice clearing fractions just so you can get used to that, okay? If you want to do it like Med just did it, it is absolutely fine. That works. It works. But if you want to clear the fractions, that also works, okay? This also works for inequalities. Because all we're doing is multiplying by the same number on both sides, it's not changing the inequality, unless we multiply by a negative. But when you're making a common denominator, you don't multiply by negatives, okay? We never multiply by negatives to do a common denominator. Our common denominator is not going to be negative, okay? So let's do another one. Let's just practice. I'm going to give you some. Again, this is out of my head, so that means that you might get something wonky. Okay, so let's see. We're going to take 1/5 times 2x minus 3/4 equals 220 over 21. No, I don't want 21. Yes, equals 7/5. I don't know, I just make these up. You never know what we're gonna get, okay? So, here's a problem. Now, you can do this problem a couple ways. What is a way that you see to do it right now? Just anybody wants to say how they would do this right now.
1/5 times 2x and 1/5 times.
Okay, so you would use distributive property, okay? Which that is a perfectly legitimate way to do this problem. I agree, distributive property. So I have 1/5 times 2. What does that give me?
2/10.
Yes.
2/5.
2/5. Because remember, this is 2/1. When we multiply, we just multiply the top numbers and then the bottom numbers. So if you need to remind yourself, a whole number is always over 1 when I multiply. So this is going to give me 2/5. When I multiply 1/5 times 3/4, which is a negative, what am I going to get? Matthew, what would I get if I take 1/5 times 3/4? So what are the two numerators?
3/20.
Yes, that's correct. 3/20. And you guys watched me and I didn't put my X in there. Don't lose your X. That will be very dangerous because you will never be able to find what it equals if you lose it. Okay? Equals 7/5. Now, why did we not multiply 7/5 by 1/5? Why did we not multiply 7/5 by 1/5?
Is it because it's in the parentheses?
Yes, because we only multiply, when this is multiplied by something in parentheses, we only multiply it by what's in the parentheses. Okay? Now, we want to get the least common denominator. What would be our least common denominator? In other words, what do both 5 and 20 divide into equally? 20 divides into 5.
Oh, both of them divided into 20.
Okay, so the least common denominator is actually 20. Okay, does that make sense? Because 5 divides evenly into 20, 20 also divides evenly into 20. Okay, so now let's see, we're going to multiply all of this by 20 and this by 20. And if you want to write it over 1, that's fine, okay, because it helps you multiply. Okay, some people like to do it like this. Instead of cross reducing, they'll just multiply. 20 times 2 is 40. 1 times 5 is 5. Okay, 20 times 3, that's minus. 20 times 3 is 60. divided by 1 times 20 is 20, equals 20 times, or 7 times 20 is 140, divided by 5. Okay, now, you can do it this way, but then you have to do the division. What is 40 divided by 5? 8. So this is 8x. What is 60 divided by 20?
3.
3. And this is going to be your harder one. What's 140 divided by 7, or 140 divided by 5?
18.
Yes, it is. Okay. It's 18. No, it's not.
Yeah, cause 5 times 20 is 100.
5 times 20 is 100. That's right. So it would be 28.
28. 9. Yeah.
Okay, 28. This is where you'll have to do a little more work that maybe you can't do in your head. Okay. It's okay to use your calculators on these. I'm fine with that. I'm just showing you don't have to cross cancel. But if you cross cancel, it actually makes your multiplication easier and you don't have to do the division. Okay, does that make sense? Okay, because I could have here reduced this down. The thing is, I would rewrite your 20 next to each thing so you don't cross it out once and think that's the new number you're going to multiply by. Okay. Now that we have 8x minus 3 equals 28, we're going to add the 3, we get 8x equals 31, divide by 8, x equals to 31/8. Because 31 is prime, it's not going to reduce. Okay, so when you do problems that I make up, usually they don't reduce. They usually come in as prime numbers. Just saying, I make them up and they don't work. Okay, questions on that? Let's see if it changes when we do an inequality. Okay, we're going to have, let's see. Okay, so here's an inequality. What do I want to do first on this problem? Yes.
Single out x.
Well, how do I single out x?
You would probably use the distributive property on the right side.
Oh, wait. So you have to do one step before singling out x. What's that?
Getting rid of the other x.
No, what did you just say? Use the
Distributive.
distributive property. Our first step here, if you see something like this, we want to use the distributive property first. Okay, so we could use this. Distribute it through. So then we have 3/5 x plus 2/3. This one does not change. 1/4 times x is 1/4 x minus 1/4. This is 1, so it's 3/4. Okay, so it's 3/4. Now I have all fractions there. Let's clear that denominator. As soon as you have it all out, so that you have all fractions, there's no parentheses left, we want to clear the fraction. So what is our least common denominator for 5, 3, and 4? What is the number that all of those would multiply into? So 40, does 3 divide into 40?
No.
No. Yes.
60.
60. So if all else fails, you know how you can get it? If you can't think of what it is, multiply the 3 together. If I multiply the 3 together, it will give us not the lowest common denominator, but it will give us a common denominator. Okay, so the LCD is 60. Okay, one way to find it is just multiply the 3 different numbers together, unless you have a 20, which you know both 4 and 5 go into. You might then just take the oddball and multiply, but play with it, okay? So I'm gonna multiply, this time I multiply both sides by 60. And we're gonna put 1 over that. So I'm gonna write it as 60 over 1 times 3 over 5x plus 60 over 1 times 2/3. It's less than or equal to 60 over 1 times 1/4 x minus 60 over 1 times 3/4. Notice, 60 is being multiplied to every term. Do you notice that? The 3x plus 5, 60 is being multiplied by it. The 2/3, 60 is being multiplied by it. The 1/4 x, 60 is being multiplied by it. The 3/4, 60 is being multiplied by it. So you have to multiply every term by 60. Okay. Now we can do a little bit of reduction. How many times does 5 go into 20? 60.
12.
12 times. So this is 12 and this is 1. So we cross reduced. There's nothing that divides into both 1 and 3. We can't reduce that way. But we can reduce this way because 5 goes in here and 5 goes in. We already know 5 goes into 60 because we just determined that. Okay? So we have to figure out how many times. So that leaves us 12 times 3, which is 36x. Okay? Now, looking at this, 60 and 3. We know 3 goes into 60. How many times does it go into 60?
20 times.
20 times. So this reduced, the 3 goes in here once, the 3 goes in here 20. So I have 20 times 2, which is
40.
40. That's less than or equal to, we've got 4 and 60. We know 4 goes into 60. How many times does 4 go into 60?
8. No.
25.
No 20s.
Not 20.
How many?
It's not 20.
15. Very good. Thank you. 15. And 4 goes in there once. Okay. 4 goes into here once. 4 goes in here 15 times. That leaves me with 15 times 1 over 1 times 1, which is 15x. Excuse me. Minus, again, we have 6 and 4, so we don't have to think too much. That's going to be 15. This is going to be 1. 15 times 3 is 45. Now, Grayson, we're ready for your next step. Okay? We could do all that before we have to get the x's together. Okay? The only thing we have to get rid of before we multiply by the least common denominator is anytime you have parentheses that uses the distributive property. Okay? So now I'm going to subtract 15x here. So that gives me 11x plus 40 is less than or equal to negative 45.
21x. Pretty sure.
Is it 21x? Oh, thank you.
Yeah.
It is 21x. See, I can't do simple addition either. Okay, minus 45 here. Minus 40 here. So I get minus 85 is less or greater than or equal to 21x. Over here, 21x is less than or equal to negative 85. Divide by 21. And that makes x is less than or equal to negative 85 over 21. What are two numbers that go into 21?
7.
7 and 3. Does 7 or 3 go into these? You can test it. The only way I can reduce this is by reducing this one by either 7 or 3. I'll tell you 3 doesn't go in there because if you add the digits, it's 13, that's not divisible by 3. Okay, so we were looking for 7. Does 7 go into that? Into 85. Well, we know 11 times 7 is 77, right? So if I do one more 7, it would be 84. Oops, doesn't sound like it goes in there. We are actually as low as we can get. Okay? That's as low as we can get. Always check to see if you can reduce. But if you did use the least common denominator here, most of the time it won't reduce. If you actually use the smallest one. Now, if you don't use the smallest one, it may reduce on you. Okay, does that kind of make sense? So if this number, if I used 120 instead of 60 to multiply by, then I would be able to reduce what our answer was because it will be doubled what it will be not doubled, but each number will be doubled and you'll have to redo it by 2, reduce it by 2 on both the top and bottom. Okay. I think we need to practice. Don't you guys think we need to practice some? Yes, we do. Okay, so we're going to start, let's see, how do I want to do this? Oh, I want people that don't screw off together. Oh yeah, okay. I know, let's do Ava and Braille today because you guys work well together. Let's see, Grayson and Mason. Ooh, that's rhyming, Grayson and Mason. Okay, over here.
I
Okay,
don't think Max and I should be together.
Hey, be quiet, Grayson.
so Matthew's gonna be there and he's gonna keep you guys on task.
Yeah.
Okay, so you guys are up here, Mason and Grayson. The 3 sons here, okay, and the girls are over there.
The triple M.
The triple M's, yes it is the triple M's.
M&M.
Yes, it's M&M and M&M.
Or 3.